Good morning or good evening. It's a pleasure here to present you the tunnel application, fire detection system in tunnel for tunnel application. These are the topics that we are going to touch, requirements that are needed for a tunnel detection system. We are going through the available standards very quickly, and we are talking a little bit about the operation of such a system. We are also looking to the fire concept for a road tunnel, which is a typical fire concept, and showing some project example before we are concluding this webinar. Maybe some words about myself. I'm more than 30 years in the security business, especially in fire detection, prevention. I'm also certified for CFPA. This is an European Safety and Security Association. And I'm actually responsible, the regional manager for all Latin American market. Let's start first with the requirements to a tunnel fire detection. What is required for such a system? We all know that it's quite a difficult application. First of all, because we have a very difficult conditions inside a road tunnel. Therefore, the system must be proved to work also against emissions about all these diesel exhaust particles that we have inside a tunnel. Then we also are faced with a high humidity, usually inside a road tunnel, but also in some cold countries, there is a lot of road salt mist also in the air, which is quite aggressive, especially with equipment or all metal housings. We have in general a lot of dust inside the tunnel, so it's actually a dirty environment. And also a big difference of temperature that we can have inside a tunnel, especially in the entrance or in the middle of a tunnel, especially in cold countries where you can have easily 15-20 degrees of difference from the entrance and to the middle of the tunnel. So this must also be taken in consideration when we design a system, a fire detection system in a tunnel, that there are a lot of variation in different sectors. Then there are also additional requirements. For example, the integration of such a system in the operating system. That means the system must have some interfaces. Today, it's very usual to have a Modbus, TCP/IP, or it could be also a RTU. There's also BACnet, but most of the integration today is done by Modbus. So this is also important that it can be easily integrated to the SCADA system. Then there must be also a system which is easy to planning, easy to install and commission. And at the end also must also be easy for maintenance, since this kind of system, they have a very long lifetime. We talk about 20 or more years. And finally, also the price must fit inside description. So this is also important, maybe not the most important, but it's important when then they have to take a decision what kind of technology they want to choose for protecting a road tunnel. What are the actions that we need to give as a fire detection system? If a SCADA system is available, which is the information tunnel management system, then it's important that the fire detection system is giving very fast all the temperature profile, the alarms or fault signals. In case of a fire, there are many steps what the operator has to do. Normally, it's also automated by the SCADA system. One of these is, for example, turn off the light signal on red to avoid other cars going inside the tunnel in case of a fire. So to avoid to get trapped or stuck inside the tunnel, this is very important that as soon as possible we can stop the traffic if there is a fire inside the tunnel. Then we also have to activate the escape route or signalize the escape route, which is important for the people that are already inside the tunnel. They must leave the car as soon as possible and try to find the shortest escape route. Then also the ventilation system is triggered. If there is a desmoking system, or simply if they have to switch off the ventilation, or if they have to accelerate the ventilation in order to push out the smoke of the tunnel. These are all information that are done after receiving the alarm from the fire detection system. Of course, the operator must also alert the fire brigade, all the rescue teams. This is everything normally automated inside the tunnel management system. And if available, there is also the triggering of an extinguishing system. Some tunnels, they have for each sector an extinguishing system in case case of a fire, trying to avoid that the smoke is moving from one sector to the other. So this is quite new. It's not very often that you have extinguishing system inside the road tunnel, but some of the tunnel already has this kind of system. Then the requirements of a TFD, which means tunnel fire detection, is as quick as possible. That's the protection goal we have, because finally we have to save people. That's the first and the most important issue of our fire detection system. Always in the fire business, first priority is we have to save the people. And then we have to protect the infrastructure. And this is also important because some tunnels today are built below, under a river or a sea. So very big damage of the tunnel structure may also be very complicated if you have water up of the tunnel in case that it's built under the river. So this must be also taken in consideration, that the extinguishing must be very fast. The control of the fire must be very fast in order to avoid bigger infrastructure problems. But then, if we say as quick as possible, we also have to consider that then we may have more false alarms. And false alarms are not very accepted, especially in a road tunnel. Why? Because if there is a false alarm, everything is, all these actions are done automatically. And then you have, suddenly you have the red light before entering in the tunnel. Then you create a queue. Then it may also be that then because of this you can have collisions, accidents, and this happens in the practice. So of course, to avoid false alarm is also very important. Other thing is, due to this false alarm, you may have a delay of the traffic, which is not very interesting, especially if it's in the rush hour and everybody's going to work. Then it's also waste of energy, because usually the ventilation system, depending on the concept, you shut down the ventilation system, and then you have to switch again this all these generators, and this is quite a big waste of energy if we consider that a long tunnel has many of such ventilator. This must also be considered that it's a disadvantage if we have a false alarm. And finally, also all the fire brigade, the rescue team that are alerted and then arrives to the tunnel, and you see that it's a false alarm. Of course, if this happens in a sequence and many times, creates also a little bit the motivation of this action force. So they don't believe once there is again an alarm, because they always think it is a false alarm. And if you have an extinguishing system inside the road tunnel, it may also be activated even there is no fire alarm. So PARC, which is the Permanent International Association of Road Congress, says as fast as required. So we have to be fast in the road tunnel. We know that every second can save life people, and for that it's important that we have to detect fast, but without false alarm. Talking about false alarm, usually in a normal tunnel, the operator may accept 1 to 2 false alarm per year. This is maybe what many of the operators will tolerate, but not more than that. It's a bit about the false alarm. Then about the available standards, I just make a resume of there are normally much more standards. Every country may have its own standard, but there are also many countries that they don't have any national standards, and they just take as a reference one of these standards, the European, the German, or also the Austrian, which are quite proof standard with many years of experience. What are these standards saying? Of course, here we are talking about how fast fire detection system has to detect in the road tunnel in case of a fire. And nothing better to show you this short video. This is a normal typical fire test, which is done inside a tunnel from the fire brigade. In this case, the fire detection system was switched off just to see how it works when we are not triggering the ventilation system. So you can see after 10-15 seconds, a lot of smoke is going up. Ventilation system is not triggered, so therefore the smoke is expanding very rapid. And we see even the cameraman will be surprised. You saw that how fast the smoke is expanding inside a tunnel. That's why it's so important that we can detect very fast in order to trigger or to accelerate the ventilation system and push out the smoke. Otherwise, the smoke is coming down, which is the most dangerous part in a fire in a tunnel. 80-90% of all heavy accidents where people dies, it's because of the intoxication. So the smoke is it's the enemy number one. That's why it's important to have all these tests to test the ventilation system together with the fire detection system. Now I just put here 2 standards: the RABT from Germany, which is quite very well-known standard. They do the fire tests, for example, in the road tunnel using a 20 liter of petrol, which generates about 5 to 9 megawatt energy. So if we consider that one large passenger car, an SUV, can produce around 5 megawatts in case of a fire. So this is, as we can see also on the picture. And then they simulate a ventilation speed, around 6 meters per second. So it's quite a strong speed. And the system must be capable to trigger an alarm within 1 minute. So these are the, let's say, a little bit the points that are inside the standard, how fast the system has to work. And and therefore the fire brigades are always proving before opening a road tunnel if the system really detects under these conditions. But we see in Austria, which is a neighbor country, they have totally different standards. They don't use petrol, they do it with alcohol, spirit, 10 liters. So the energies what is generated with this fire test is quite lower, only 1.5 megawatt. But on the other side, they just use 3 meter wind speed instead of 6. And also here, the system must trigger within 1 minute. So they do different fire tests. They also do fire tests with diesel, for example, or 5 liters of petrol. So they reach 3.5 megawatt. And then they speed up a little bit the ventilation, because the faster is the ventilation, more difficult it is also to detect the temperature on the top of the ceiling. Also here they have a limit of 120 seconds. So those are some typical standards that are in the every national regulations. Not all have this regulated in their standards, but it's important because this is where they measure the system at the end. And then according to the Germany standards, the RABT, why linear heat detection system and why not point detectors? It's also possible to have point detectors because to measure all these complex heat radiation, heat convection, and heat diffusion, it's very difficult. Point detector in the practice show that it's not working properly. And therefore, we can say that the new type of line heat detection system, they really fulfill all these various requirements inside a road tunnel. And also, we could see in the praxis many years of experience that this is really the right technology to be chosen for the protection of a road tunnel. Before I enter in the principle of operation, I would like to ask you if you have some question that I can maybe answer you.
Mimo, we have a couple of questions, and the first one is how many derivations are possible with the Listec sensor cable?
Yes, good question, because derivation, that means you can adapt an installation during a project phase or during the installation phase. And here our system is very flexible. We are actually unlimited derivation are possible. So even you have to repair or even you have to just extend the cable to protect other areas, parking areas, for example, you can do so many derivation as we don't increase the maximum number of sensors that I will show you later on the characteristic of our system.
And the next question is, what is the advantage of Listec comparing to other linear systems?
Well, the advantage, I think it's for sure the most fast linear heat detector we have on the market. It's a very sensitive system. We operate with a fixed sensor inside the cable. We have the exact location. That's also very important. When we detect a fire, we know exactly which sensor was triggering and what is this position. This is also very important because the position of a sensor may be determined to activate cameras in the same sector to trigger fire dampers. So this is very important. And then finally, it's a very proved system over decades. And also there is no maintenance needed for such a cable. I'll show you also later. These are all advantages that I think it's for the operator, it's very important. It's really for a long life.
Mm-hmm. Can the sensor cable have other sensor distances than the standard one, say, for example, 3 meters, 6 meters, something like that?
Yes, the cable can be produced with really different sensor distances. We keep minimum distance of 0.5 meters, and up to 10 meters we can really choose what sensor distance we would like. We even can have a 1.5 meters or 2.75 meters. It's really this can be produced according to the design also.
Mm-hmm. And are the sensors addressable?
Yes, each of this sensor inside the cable has an address. That's why it's important, because we will get exactly information from the sensor. We know exactly the position, the location, and also then we can adjust each sensor individually. This is also very important. Yes.
And can each of the sensors be configured individually?
Yes, this is important. As we talked at the beginning, we have different temperature in the entrance of a tunnel, in the middle, the end of a tunnel, and therefore it's important that some sensors have different sensibility than maybe other one where we don't have a lot of variation of temperature. In an entrance of a road tunnel, you can have easily quickly 10 degrees difference, temperature difference if there is a cloudy sky and suddenly the sun is shining. So this affects a little bit the first sensor inside the tunnel. And therefore, we can adjust the sensibility because every of the sensor is individually adjustable.
Mm-hmm. Thank you, Mimo. We don't have any further questions. We shall see if there are more questions towards the end of the webinar. Please continue. Thank you very much.
Thank you. Well, the principal operation of such a sensor cable, also called chip cable, is you see here the sign of this cable where we can see the sensor, which is built inside the cable. It's quite a very difficult process to implement this sensor. It's quite a complex process. But then once we have this the electronic part inside the cable, then we have this protection, aluminum protection, which gives to the cable also a mechanical resistance. It also is a heat conductor, and at the end also we have to avoid external influences. So that's why it's also important the aluminum protection before we cover this with the halogen-free cover of this cable. About the resolution, which is also important, it's 0.1 degrees. It's quite a precise sensor. This is also very important. Maybe in the road tunnel application, it may not be most important to have such a precise resolution, but in many other applications, of course, this is very important to have this resolution. Then, as we just answered this question, we can have different sensor distances. The normal one, the standards one, are started by 2 meters, 1 meter, 4, 5, 8, 10. But as we also answered before, we can have all the distance. And normally, up to 10 meters, it does not make sense to have a sensor with distance more than 10 meters. It's like if you have a temperature point detector, you also have to keep maximum distance according to the fire detection norms. Then what are the functions of such a sensor cable, especially the SecuriHeat list sensor cable? Here we can see that we can have on one system, which is composed of one controller, 350 sensors inside the cable. That means that with a distance of 10 meters, we can reach maximum 3,500 meters with one cable connected to one controller. This is quite a long distance for a cable with electronic components. Then very important. Here we are talking about rate of rise and maximum alarm detection. So we are not detecting only a maximum temperature. We are detecting, and this is important, 90% of all the cases of fire alarm is detected by the rate of rise. So that means the increase in temperature in a short time, this must be detected. And this is very important that when we choose a linear heat detector, that it's really able to detect rate of rise and not only the maximum temperature. Then we know that for each sensor, which is individually addressable, we can have the temperature value from this sensor. This is important because at the end we will have a temperature profile on the tunnel management system, and therefore it's important to get the exact temperature of each sensor inside this cable. Then we have the possibility to have an installation where the cable is working in a redundant version. That means we can have, I show you later on, the fully redundant option, which is 2 controllers, one at the end of each end of the cable. And that's important because in case of an interruption or in case of a damage of one controller, the system will keep working. This is quite important because especially city tunnels, they must switch off, or they must close the tunnel if the fire detection system is not operating. So therefore, it's important to have a redundant option in these special cases. Then the installation, you can see we can have different derivations. As I was mentioning before, you can have a derivation, for example, to cover a parking place and also using a difference sensor distance. For example, here we use 4 meters because it's a small place, so we would like to have more sensor concentrated. And on the main tunnel ceiling, we can have a sensor every 10 meters. So we can also choose different sensor distance together, mixed up together with other sensor distances. Then also important to know, because at the end we are talking about electronic components in the cable. If there is one sensor which is getting full, can be due cable interruption, an accident, which maybe cut out a few meters of the cable, the whole system will not shut down. So everything is working, every other sensor is working inside this cable. And this also due because the sensors are protected. They have like a short circuit isolator, so we can isolate the faulty sensor in a manner that the rest of the system is working without any problem. Then the operating temperature, which is for a road tunnel, it's no problem at all. So we work from -40 up to 85, and also for not a long time, the cable is also working around up to 200 degrees. But if we have a fire and we will have, of course, more than 200 degrees, of course, there will be a damage on the cable, but after a fire, we have to exchange everything inside the tunnel. So this is not a problem. The most important thing is that we detect the alarm, and then if the cable will be damaged after 1 hour or 2 hours, this is normal, because a fire inside a tunnel will reach very, very high temperature because it's actually not very high, and all the energy of this fire will be encapsulated inside this tunnel. That's why it's important that the detection is made very fast. The resolution, we always already talked about that. It's 0.1 degrees. The detection of infrared heat radiation is also important because that means that the sensor to activate an alarm, the does not need only that the temperature around the sensor is going up. We can also detect the radiation in case that we have a truck standing below a sensor and the engine is overheated, for example. Then all the cover, the metal part, is overheated, and this is emitting infrared radiation. And this radiation is also possible to be detected by the sensor. This shows how sensitive the sensors are, and that's why this is very important also that can have a detection even the temperature on the ceiling is not going to change. Then fully protected against external influences, which is important, especially in application like metro tunnels where we have high voltage cables, but also in a normal road tunnel we have high voltage cable for the ventilators. So that means the system, even with electronic components, is proofed against these external influences, electromagnetic influences in these cases. And finally, maintenance-free sensor cable. We see the electronic is really fixed inside the cable, and then it's covered. So there is no maintenance needed. There's no electronic that you can reach in the cable. That means all the components, all the sensors are communicating every second with the controller, and that is actually the proof that all the sensors are working. If it's one sensor is not communicated, then we have very quickly a false signal. So actually the cable will not need any maintenance, and only maintenance we suggest is that normally you do some fire tests or you trigger some sensor in order to check all these actions that are behind such a system. Then the fire detection concept in the road tunnels. There is not only the tunnel that we have to take in consideration, we have also different technical rooms. But first, if we see in a concept in a tunnel management system, you have here one of the sensors is the line type heat detector. Of course, it's not the only one. We have a CCTV, which gives us also information. We have this visibility monitoring system, carbon monoxide detectors, and we have much more sensors inside the tunnel. All this information is going to the operating system. And then according to the concept of every tunnel operator, they may have then the measures that in case of an alarm, lean heat type detector must activate the ventilation or must turn off and red traffic lights, or we can choose the CCTV camera in this sector to really confirm if there is a fire or not. All this information are actually then part of the SCADA system, which is determine how are the actions, what kind of signal they need. And also extinguishing system in a tunnel, you may have a double or two detector dependency. That means you can have maybe a special fire detector, point fire detector in a road tunnel, or you can combine also with information of visibility monitoring system, so that you can see we have heat, we detect the heat. Now we also have smoke in this sector, and only then we can trigger the extinguishing system. So that depends a little bit of the concept of the operator of this tunnel, how he's acting with his informations. Then we are not talking only about a linear heat detector in a tunnel. We also need to protect different other rooms. Therefore, we need a fire control panel. We need a multiple sensor detector that are able to detect smoke and heat in combination. I'll show you why. Also, aspiration smoke detectors, which are quite high sensitive smoke system, are also needed in some of the application, which has a very big advantage if you use this kind of technology. And also, finally, we have manual call points, we have sirens, we have flashlight inside the tunnels that also needs to be controlled and connected to a fire control panel. Let's see some project examples, how this may work. If we see here, typical one tube road tunnel, we have the temperature sensor cable with sensors every 10 meters. 10 meters, this is more than enough. You don't need to have really a location every meters, because if there is a fire, we can see very easily where the fire starts from far also. That's why 10 meters, it's like a standard in a normal road tunnel. Then here we have a redundant design. That means we have two controllers. And this is because in case of an interruption of this cable, then the cable will work on one side using the controller on the left side. On the right side, the controller is keeping working all the sensor from the left sectors. Then normally the controllers are connected by TCP/IP Modbus directly to the SCADA management system, because the operator would like to receive a temperature profile. So all few seconds we are sending the actual temperature of each sensor to the operator, which is very important because he can create a graphic with a real temperature profile inside the tunnel. Can be important also to see how high is the temperature in the middle of the tunnel. As I accelerate the ventilation to cool down a little bit. So all this information are important. Also, from the interface, we can send the alarm signal. We can also send fault signal. But we always need redundancy, because if this interface is interrupted, at least we have to give some information to the fire control panel. This we can do via relay contact. So in general, we can have one contact per zone, and then a general fire alarm contact or a general fault contact. So we have a double redundancy. If the communication is interrupted to the operator by the interface of the controller, we still get an alarm on our fire detection panel. And the fire detection panel is also connected by interface or by relay to the supervision system. This is important to have this kind of redundancy inside this fire detection system. Then another example of a redundant design, when we have two tubes, one-way traffic, and then we can also see here, you can have the cable installed, connected with the other cable on the other tube, and then also place two sensors, maybe in the same technical rooms, but with separate power supply to keep also physical separation and to guarantee the redundancy. And also here important, the connection to the fire control panel. Then the installation of a temperature sensor cable. You have here special cable clips, depending a little bit on the roof. If it's a very nice and regular roof, you can connect this directly on the top of the roof. Otherwise, you can use a steel messenger cable, especially when we have an irregular roof. And then it's easier to install the cable before the messenger cable, and below you can fix the sensor cable. So those are some accessories that are available, and that you can choose then the right accessory for the typical roof you will have in a road tunnel. Then maybe a few words to the fire control panel. Today, it's almost a must to have an addressable fire control panel, because first, these panels are also integrated by relay contact, but also directly by an interface, Modbus TCP/IP interface, which is very common for the SCADA system. So therefore, it's a need to have an addressable fire control panel. Then we can also have, if you have more than one panels, a network, so that we have our own control panel network. In this case, also high security in case of a problem with the interface to the operating system. We keep all the panels together connected, and this is then a redundant design. Then another task of the control panel, of course, as I mentioned before, is the multiple point detectors, the push buttons that we have to control inside the tunnel according to the local fire standards. But also we can monitor, for example, the extinguishing system, which are placed inside the tunnel, or some escape doors. So as soon one extinguisher is active, if somebody takes an extinguisher, then we can get also an information to the operator that he can check with the camera exactly what happens there. Is there a car in the middle of the tunnel, which somebody has to extinguish the fire, or if somebody's opening a door, we can also trigger this via contact and bring this information to the alarm panel, and from there to the operator system. Then a typical project design, if we consider that the tunnel has many technical rooms, these technical rooms must also be protected, and usually here you take point detectors, since these are small rooms. The advantage to have multi-sensor detectors is because you never know if those rooms are clean or not, but in case you have a multi-sensor detector, you can finally, in the end commissioning, decide if you want to use only temperature, or if you want to combine with smoke and temperature. Sometimes you can also use the smoke sensor as an information, not to trigger an alarm, and then you use the temperature sensor to trigger the real alarm. So you can avoid, if you have an intelligent combined smoke and heat detectors, you can avoid false alarm because you have this flexibility to configure the detectors according to the environment. Then every tunnel has also its control center. This is a little bit the brain of all the system which has to control a road tunnel. And here you have a lot of information, a lot of cabinets with all the components, with all the controllers. And these are today, depending of the road tunnel, like small data center. And therefore, I mentioned the aspiration smoke detector, that here it's a very nice application if you use such kind of aspiration smoke detection, because it's much more sensitive, so we can detect in a very early stage if there is some short circuit inside one of this cabinet. We can also protect the false floor or the false ceiling. So usually one equipment can be installed, and then you have beside the conventional point detectors, you have also this aspiration smoke detector. Well, some success stories, maybe to show you a little bit what we have done with this sensor cable from Listec. We have a very nice town in South America, in Santiago de Chile, this tunnel which was constructed under the city. And part of this tunnel is going under a river. Therefore, when I mentioned at the beginning, it was a very important part that when they choose the system, that it must really detect very fast, because if you have a fire inside a tunnel and then there is a river on the top, this is quite critical. Therefore, they choose the most, let's say, the fastest linear heat system to protect this strategical tunnel, which is in the middle of the capital of Santiago. Then we have also still staying in South America, of course, because it's also a little bit my region here, but it's also a very important project, the most important tunnel project at the moment in Brazil, which is connecting, it's a road which connects the highway to the down to the coast. And these tunnels are going through the Atlantic forest. So it was quite a very complex construction because on the other side, they had to protect all this part where the construction is going through this forest. But therefore, this is today one of the most, if not the most important tunnel project ever done in Brazil. And we are proud that we could protect this with our technology, covering almost 30 kilometers of these tunnels totally. But then we have worldwide much more also interesting references, like this one here in Switzerland, the Gotthard Tunnel, which belongs to one of the longest road tunnel in the world, with 70 kilometers. Here we can also be proud to have this technology chosen for protecting this very important tunnel, at least for Switzerland, passing thousands of cars every day. And on the other side of the world, of course, we have also hundreds of success stories. I just picked one up. This is this Yanpyeongman tunnel in South Korea, which is also almost 8 kilometers long. So we have today more than 3,000 kilometers of road tunnel protected with this technology. We can say they are proven technology. See this kind of strategic important road tunnel we protected using the LIST sensor cable. Then coming to the conclusion, we'll see fire detection concept consists of line type heat detectors. This is a must to prevent, to trigger especially the ventilation system, the traffic lights, the escapeway control, and much other systems. So the fire detection system has a very important role inside the whole concept, the whole design of a road tunnel. And that's why it's very important all the actions are taken when the fire detection system is triggering an alarm. Step 2, we can have additional smoke information, of course, using maybe the carbon monoxide sensors or some other visibility sensors we have inside the tunnels. These can give additional information to the operator that there is smoke inside the tunnel, but normally only when the heat sensor is detecting presence of temperature, only then the actions are taken by the operator. In step 3, if we have a second fire detection system, we can also then trigger an extinguishing system. So this is very important that the fire detection system, what we choose, is really working properly inside a very difficult ambient where we saw that there is a variation of temperature, where we have a lot of dust, a lot of contamination, aggressive gases, and this system has to work for many years, 20, 25 years. This is what we expect from a line heat detector linear system. Finally, that such pictures we don't see anymore. We have learned about all these fire accidents, and therefore every time the fire detection system has a more important role inside concept. And this is only possible if we have the right fire detection system. We can maybe not 100%, of course, avoid such kind of catastrophes, but we can at least maybe have less such kind of accident in order to don't have this big accidents in our history. Thank you for your attention, and if you have some more questions, please feel free to ask.
Thank you, Memo. We have got some questions, and the first one is, what is the maximum temperature for the sensor cable? to function?
Yes, the function of a maximum temperature cable, I mean, if you mean what we can, when we have to trigger the maximum temperature, normally we set how fast the system have to trigger increase of a temperature. This depends really a little bit of the conditions. Maybe we are talking about 1.5, 2 degrees per 60 seconds. And then we set a maximum temperature alarm, which may be around 45, 50 degrees. It depends a little bit what is the highest temperature that we have normally in a road tunnel. So we have to be a little bit above this temperature. That's why we have in combination the rate of rise and the maximum temperature.
And how to program the list controller? So is there a software or something like that?
Yes, there is a software. There are two possibilities. We can also pre-configure the system so that you can install and almost, let's say, plug and play, and then the system has a pre-programmed configuration. But normally with the software, you always do the fine-tuning, so you are then checking about what are the real temperature inside the tunnel, and then you use a software tool to configure each sensors and adapting the configuration and then sensibility to each sector of a tunnel. This you can also do by remote, so we have also remote access. So there is no always need to be inside the tunnel. If we have this connection, we may also do the fine-tuning later on after a few weeks if there is a need to adjust a sensor.
Mm-hmm. So the next question is, we got a question in the chat. So somebody's asking, so for example, if there was a fire and the sensor got into the heat, what's the maximum temperature for sensor to survive for next use, so for reusing?
Yes. As we saw the specification, normal operating ambient, it's 85 degrees. So if the fire, it's not a big fire, but it may reach up to 200 degrees for maybe a few hours, the cable will still working, so we will not have any damages. But if the fire is really taking for hours and hours, and the temperature are increasing over this 200, 300 degrees, then of course there will be some damage. And then what we suggest is to replace maybe this part, could be 50 meters, it could be 20, depending on the damage. Then we suggest replace this part of the cable. But if we reach 200-300 degrees on the ceiling, it's not the only cable that we have to replace. There are also all the components like CCTV cameras, and all these components are not working after such a fire. The advantage is that we can easily cut out 50 meters of the cable and replace it. So this is very easy to replace. There's no need of special tools. We don't need a special technician with a special know-how to get in the tunnel and make this replacement. We can do that easily with connection box. So that's actually no problem to replace after we have damage.
So that means the if something gets damaged in the middle, you can just fix it, and no need to buy a new one.
No need to buy a new one. No need to replace the entire sensor cable. So really, you just replace the damaged part. And once the cable is damaged, if we think that it could be damaged after 200, 250 degrees for many hours, of course, the cable has done its job. I mean, we have to detect in the first stage of the fire. Once we give the alarm, then it's not important if then the cable is damaged after a fire accident. That means we have to replace, as we have to replace other cables and other components inside the tunnel. Important is that we trigger the alarm before it is damaged, and this is fact.
Okay, so is there a need to calibrate or configure the sensor every 2 years or every year?
No, the calibration is actually done in the factory, and once we install the sensor cable, there's really no need to make any adjustment. You can always change the sensibility of the sensors after a year if you want to have or increase the sensibility, but there is no need of any adjustment, no maintenance. That means when you really install the system, then it's working for its lifetime without to need to have any special configuration or calibration on the cable.
The next question is, how many controllers can be connected in a network?
Today you can have around 32 controllers in a network if we consider that every controller can have up to 3.5 kilometers of sensor cable. That's it's quite a very big system you can create with 32 controllers in a network. So that's the limit we have today. But more important is that every controller is always connected directly to the SCADA system by the internal TCP/IP interface. So most of the operator maybe does not care if the controller are in a network under them or if they are individually connected by their interface to the operating system. But we have 32 controllers in a network. That's our capacity.
And what is the lifetime of a sensor cable?
Lifetime we have today, and then we see also a little bit the reference project we have. I personally know many system installed since 20-25 years, so we are talking usually about 25 years. Many countries have some regulation where you have to also exchange the electronic after 10 years, 15 years. So this is not the case for the cable. Maybe the controllers can be changed after a new generation, but those are normally always compatible with the cable. But the cable, once you have it installed inside the tunnel, you have it for really 10, 20, 25, even 30 years.
Thank you, Mimo. We don't have any further questions, so thank you once again. And we look forward to seeing you all for our next webinar.